Hi everyone, welcome to another video in the CBM Flux Studio series. You may recall from a previous video that I wrote a tool that runs natively on the Commodore 64 to fix the illegal GCR sequences in track 10 of Zaxxon, so that a clone can pass the protection check on weak bits in that sector. Today we will have a look at how the very same operation can be performed in CBM Flux Studio. So first thing, let's open a G64 for Zaxxon, and I could realign all tracks so that we get sector 0 at the beginning, but I'd like to do as little change to the G64 as possible. So let's just navigate to sector 0. We should be in the neighborhood of this one. So this is sector 1, and this was sector 0. You can see from the tooltip. This is the block sync for the header of that sector, and this is the block sync for the data part. Now the track is not aligned in a way that we get the right framing for this sector specifically, but in this version of CBM Flux Studio, if I use Alt and cursor right, then I can rotate the track data by 1 bit cell right, and now we can see the familiar value 55 in X, which is the first 8 bits of the GCR encoding of the data ID. So we're good with the framing. What we need to do now is to double check that the sentinels are in place, which are values that the protection checks for explicitly, and those are D5 after the 55 of the block ID. So it's there. Then there is AA, that's not a sentinel, and then there should be an area with all bit 0 bit cells, and the way to do that in Flux Studio at the moment is by holding down Shift and clicking on the track, which erases 8 bits at the byte boundary where the mouse pointer is. So the way to imagine this is as if we were using the byte ready flag, and the byte ready flag is now aligned with each byte that I'm removing. So I need to remove 3 bytes in total, so that's what I'm gonna do. This is the second one, and this is the third one. What comes after this region, this gap, should be another sentinel, again a value that the protection checks for explicitly, and then D4 after AA. So AA is here, and then D4 is here as well. That's fine. We have everything in place. If for some reason during read this the framing of these values had changed, we would have to fix them, but nothing else on this sector, because all other values, the rest of the content of this sector is not checked by the protection. Finally, in order to minimize the amount of changes that would be displayed if I were to diff this track with the original file, with the one in the original file, comparing the G64s, what I can do is Shift and cursor left and bring it back to where it was. Now what I can do is to save it. Let's call it test.g64, and that's about it. So test.g64 just popped up here. It's 10:04. Yeah, that's right. 10:04. So let's first load the original G64, and I show you that the drive code navigates to track 1 and then hangs there. It hangs there because the illegal GCR sequence doesn't contain enough 0-bit cells to cause different reads at different passes, so it keeps reading the same data consistently, which is expected to be the case when the protection is not in place. Let's try the G64 I just created. Yeah, went to track 1, passed the protection check, and is now loading. Just switch to warp mode so that it's quicker. As you can see, the game loads. Let's have a little play as well. Right, I'm not going to play the whole game, but that was about it for this one. I hope you enjoyed the video. Thanks for watching and see you in the next one.